basically known as Edge Impulse. This is one of the latest one, the advanced one, and widely used platform for creating high-end machine learning applications. And you can start building your embedded machine learning models today. Like in terms of, it is exclusively targeting the hardware devices. If you are having Arduino Nano or maybe your Raspberry Pi or Jetson Nano, this is exclusively for targeting those devices. So previously we had seen Edge Impulse. It is basically for computers. If you want to transfer your model for hardware, there was an option of TensorFlow Lite. It was based on Google's technology. Edge Impulse are having their own open source models which they have deployed on the Edge Impulse cloud. And when you go to the studio.edgeimpulse.com, you need to create your account first of all. And once you have your account, you can log into that. So I'm sharing that login screen right now, and I'm entering into my login using my credentials. So remember this name, Edge Impulse. Edge Impulse and Arduino have tie-up, and currently in Harvard there is one course exclusively on tiny machine learning, and it is under Master of Science program for computer science students as an elective subject. And Reddy, Vijay Reddy is actually the leader of tiny machine learning course in the Harvard University. So if you are interested in this sort of Arduino Nano kits, there is an option on the Edge Impulse website that as a faculty you can apply for the Edge Impulse University program, and they will send you some 10 Arduino Nano kits with camera and other boards also. So this is one of the photograph of that kit. It comes from Arduino, Harvard, and Edge Impulse. So this is an interesting board which you can get for free. You need to simply write to the custom office at Delhi. Otherwise, they will charge you heavy taxes on that. But you need to convince them that this is for educational activity and for my college or university, you will be able to receive them for free. I received them these 10 kits 6 months back, but they are very good in terms of giving to the students for making their projects on embedded machine learning and other areas. So the only beautiful part of the this particular kit is to get the camera itself with that. Otherwise, you need to buy a separate camera, and this is a kind of a specific designed PCB where you can put your Arduino Nano on there. You can attach the camera, so there is no need to do wiring or soldering on the board itself. So you can try for this. For 2020, the website shows that it is over now, but you can also look for the kit in 2023. So if you apply in 2023, you will definitely get them. You need to simply provide some sort of SOP kind of a thing to them that for which purpose you want to use this. So when you log into your Edge Impulse, you get different options for your Edge Impulse project or create a new one. If you want to create a machine learning application for your hardware, and there are lots of other supported boards which we will be able to see them on the screen itself. But when you start on create new project, it will ask you to give a name to that. So say for example, right now I'm giving a name called HRDC just for having name. So choose your project type, what sort of project you are developing. So we do it for educational purpose, and normally it is up to us for the choose the developer option. If you have paid some money to them, it's not a paid platform, it is totally free. But if you want to use it for your enterprise application, then definitely there is an option for enterprise. But when you create a normal account, it is by default a developer account. So create new project. Okay, now it asks me for number of options. You are ready to add real intelligence to your edge device. Edge device means our normal hardware. Let's set up your project. What type of data are you dealing with? So we know our project title, we know our aim, or we know our problem statement we want to solve using machine learning. So we know our data type. I mean to say which kind of data we are going to use. If you are going to use the accelerometer data, the XYZ position of acceleration in XYZ position, we can go for the accelerometer data. If you are interested in that sort of bird related sound project or infant crying sound or maybe any other mosquito wing beat sound, something related to that, or maybe a human voice, or like Amazon Alexa, we want to provide some sort of intent detection to the edge devices, then we can go for the audio data. It listens to what is happening around you to create voice interface, listen to keywords, detect audible events, or to hear what is happening around your device. So even you can make a very small project for identification of the language. Whatever language is being spoken, maybe specifically for Indian languages, the normal popular Indian languages like Hindi, Gujarati, Marathi, Tamil, Kannada, Odia, etc. So you can identify this sort of language from this sort of audio project. If you are created in deep learning or image classification related areas, you can go for the images, add site to your sensors with image classification or object detection. So if you are targeting images related edge impulse project, definitely you have to connect your camera to the Arduino. Otherwise, for other two options, there is no need of camera into that or something else. Maybe you have different data in terms of an Excel sheet, or maybe you have downloaded human activity detection data, or maybe you are having brainwave data in terms of EEG, or maybe you have heart rate data that is not listed over here. So you can click on something else, which will give you different options into further part. So maybe like if you go to accelerometer data, so again, there are two options. If you are already having the board of Arduino Nano or any other board which is being connected with the sensor called accelerometer, then you can connect your development board. There is a kind of a little bit tricky procedure which is provided on the documentation part of the Edge Impulse platform. You need to follow those steps. They are clearly given with the screenshot. So you simply follow them, and finally you can connect your board to your computer in which you have opened the Edge Impulse Studio and you have logged into that. It will actually connect a web socket for that, and finally your sensor data will be directly flowing to the Edge Impulse Cloud platform. So this is the first option to connect your development board. Simply connecting the development board with the computer is not going to work. You need to simply install some required libraries and some softwares which are required. You install them first and then finally connect your board. You will be able to transfer your data directly from your hardware board to the cloud of the Edge Impulse. So that is the first option. Or maybe you can use tutorial, continuous motion recognition, follow our end-to-end tutorial to collect accelerometer data, train a model and deploy it back into your device to analyze movement in real time. So there is an option of reading that tutorial which is available in the documentation section of the Edge Impulse. So this is something very good documentation which has provided with a YouTube video where you can follow the steps, and finally when your device will be connected, it will be available here like the ST microelectronics device which is available and connected with your Edge Impulse platform. So this is, you can compare similar to cloud-based Arduino programming. Those who are well versed in Arduino must be knowing that there is no need to install the Arduino IDE into your computer. If you have an Arduino Studio login account, you can connect your Arduino to the computer, and finally you will be able to write a code on the web cloud, and finally you will be able to deploy that or load that code or the firmware to the Arduino itself. So this is similar to that. Okay, now if we use this connect your development board here, right now I have not connected any board to the hardware, but just to show you that these are the options of the board which is being supported, officially supported by the microcontroller unit MCU targets: Elif, Ensemble, Arduino Nano, Arduino Nicla Sense, Arduino Nicla version, Arduino Protena, Expressive, that is basically ESP32 or Node MCU. Hymex is a board which comes with a camera. Infineon, Nordic Semiconductor related series of devices. Other GPU supported targets like Intel based Macs or Linux, Nvidia Jetson Nano, Raspberry Pi 4. Community boards like Arduino Chem, it's a very good board, comes with a tiny machine learning development kit. Blues Wireless WAN, Rec Wireless, Seed Studio. Seed Studio is also providing very good boards for development purpose. So right now the Edge Impulse platform supports this much of boards. So now here comes the dashboard part where it shows that you are ready to acquire data, because for any machine learning project we need enough amount of data. So we need to click here, let us collect some data. So it will give you an option that from which place you are going to collect the data. So when you click on collect data, you will be able to see that it shows you a connect a fully supported development board. So you can simply click on here, browse the development board which are being supported by this platform. You can connect with your computer. But as I told you that before that, you need to install some of the tools and libraries into your computer. So follow those steps and then you will be able to directly use the data coming from the fully supported development boards. Maybe if you are not having any sort of board right now, or maybe any sensors are not available with you, you can definitely use your mobile phone. So when you click on the show QR code, it will actually create a QR code for you, and then finally you can open your camera and scan that QR code, and you will be able to connect your mobile phone with the Age Impulse cloud platform itself. So right now you can see that my phone is connected because I scanned that code and my phone is directly connected. So my phone is basically showing me this sort of options to me right now. I don't know because of that background. Yes. So it gives me various options that collecting images or collecting audio or collecting motion. So these are some of the data which I am able to get. So maybe like I click on the collecting motion, I will move my phone here and I will try to generate some sort of accelerometer data from my mobile phone itself. So let me click on collect motion, get started, get access to the accelerometer, start recording. So now if I am moving my phone like this, I'm keeping it like from left to right, start recording. Uploaded means my data has been uploaded on the cloud platform. Now again I am taking some data, it's again uploaded. Okay, if I now go to devices in this particular pane here on the left side of the screen, you will be able to see that my phone will be available there as a connected device to collect the data. Okay, you can see here mobile phone LMB6080. That is a kind of a number, random number which is given to this one. It's a mobile client, accelerometer and microphone data, and connected at 1042. Okay. If I click on data source here, see this is from the QR code. Actually, I need to go again back to the dashboard to show you other options which I want to discuss. Okay. Let us collect some data. I click here. So I use my mobile phone by the QR code. If you want to use your computer, capture audio or images from your webcam or microphone or from an external audio device, you might have lots of various options to connect with your computer. So this is also an option that you want to capture images. Like in morning, we took images from our webcam, but that is through teachable machine. So similarly here also, you will not get that sort of user interface, but you will be able to collect images from your webcam microphone, webcam camera, or maybe an external microphone may be connected to your audio jack with the computer itself. So that is also an option to collect the data. Maybe there is an option to collect the data from any device with a data forwarder, like capture data from any device or development board or a serial communication in 10 lines of code. That you again documentation is provided. So you might be having a different sort of device which is not supported by this platform, but you want to forward those data from that particular sensor to your computer. This is the option you need to go for that. And finally, if you are having already some data into any format, into any folder, maybe I have a folder for say Kishore Kumar song and maybe Lata Mangeshkar song and something like that. I want to make a classifier for identifying who is singing in the song. So I might have a data in terms of audio songs exclusively sung by a male singer or a female singer or different male singers. And I want to classify them while when the song is playing, it should be able to identify me the singer name that I want to do. So I might have and maybe lots of MP3 files are or MP4 files are there, or maybe in an AVI format or a DVD format or JSON format. There may be numerical data, CSV and Excel sheet. There may be a census data or Aadhaar card data of number of users and having their annual income kind of a thing. And I want to make some classifier of rich, poor, and middle class or something like that. I will be able to use this data from upload option. And finally, integrate with your cloud. You might be having your own cloud as a company and you want to, but that does not apply to us because we may not have that sort of high-end infrastructure for source of data. So this is an option which I would like to discuss here, that you have full freedom, even though without any other hardware or the sensor, you can start building your machine learning application by collecting the data from the best option, which is known as use your mobile phone. This option actually gives you to use your mobile phone microphone, use your mobile phone accelerometer, use your mobile phone camera to capture images or video. This is the best one. Or maybe if you're already having Arduino Nano, go with the first option. Okay, now coming back to again to the data source. Right now, no data source is created because actually my phone was disconnected. Data acquisition. Okay. Now, when I click on data acquisition, it shows me data collected for 2 seconds. Means I have two different samples. When I moved my phone, it actually captured the data for 1 second. So within 1 second, it has generated lots of data for acceleration in X, Y, and Z direction. And I have captured two samples just for example. Now, the thing is, here there is no option of providing labels or classification. So I need to either click here and if I edit them and provide a label here, that edit label, maybe I can give a label like shaking. So this data were specifically for shaking kind of an action. But remember one thing, that there should not be a spelling mistake or maybe capital small, because it understands as a unique label for that. So if I take lots of data of shaking and it immediately shows me the graph of accelerometer value also. This shows that acceleration in X direction, it is in red, in green it is Y, and in blue it is Z. So it shows me this sort of shaking action. Again, in this also it shows me a different. So variety of data, variety of movements are there, but I'm collecting these data for training purpose of my machine learning model. Now, to have a very good model, we need to have thousands of such data which we need to collect with different labels, because we want to classify them. Whether normally what happens whenever we are using our phone, like say I'm using my phone like this, but now I want to change the song of my Spotify whenever it is playing. If I shake my phone like this, it should change the song. So a machine learning model has to identify what sort of activity I'm doing while shaking my phone, whether it is a kind of a up down motion or maybe a kind of a left right or maybe a push pull kind of a thing or close farness or something related to that. So that would be able to identify the model will be able to identify that sort of kind of an activity, and it will give me finally some action I can take on that. So if you do not have something or don't want to record them, here there is again an option that upload existing data. You might have your Arduino and you have captured lots of sensor data from the Arduino itself, and maybe it's available inside your computer. So you can simply use upload option, and whenever you upload the data, there is already a kind of a label which you might provided. So this will upload directly the data into those labels which is available with the Excel sheet itself. The cloud platform is a bit slow, so it is taking some time when I click on any of the link. So here there is an option to upload the data. Choose the file. There are lots of different formats being supported. Here there is an option of upload into category like training or testing. Usually when we create a model, when we train the model, we use the data for training purpose, or sometimes you want to upload some separate data for testing also. At that you need to keep in mind that which radio button you are selecting. You want to get or capture the label automatically, you can use this option infer from file name. So maybe there is a file, CSV file called shake.csv, which contains thousands of data in different rows. So maybe the name of the file can be a label of that particular training data. So I need not have to provide and edit all the labels all the time. So it is better to leave it as it is, or maybe leave data unlabeled, or maybe the enter label while uploading the data. If you are uploading some sort of video or an audio file or a photograph, every time you want to provide the label, it is better to write here something, or maybe have some sort of separate files, and based on that you can get the label out of that. So this is one of the option to upload the data. Going back to the data acquisition part again. So we are here again. In this particular workspace, it again gives you an option here to connect using web USB. If you have data which is to be obtained from the board which is connected to your computer, but you want to directly transfer, you don't want to upload them exclusively. You want to directly transfer those data from your accelerometer board to directly the cloud platform. So USB web is a option which is available here. So again, click on that and you will be able to get that facility to upload the data. So this platform provides you enough options of generating data, collecting data, uploading them. Almost all the options are covered in whatever way. You will not stuck up anywhere. Even if you don't have, you can use your phone finally for creating the data or generating the data and uploading them to the cloud platform. When you have this sort of data being uploaded here, there is a kind of a pie chart which is shown here, train and test split. Right now, I have only two samples. In fact, there should be thousands of samples available here when we are actually creating a machine learning model. So at that time, maybe your 100% of data, maybe I have say 1000 rows or maybe 1000 samples which has been uploaded. Out of them, shaking has 500, maybe another gesture for throwing, say for example, I might have 500 samples, but I want to use them for training purpose. So what I need to do is that I need to again provide some sort of data for testing them. So whenever I give the label or the splitting the data set into two different portions, maybe I need to use my 80% of the data for training purpose and 20% data for testing purpose. It's not a thumb rule, but usually people do 80% for training and 20% for testing them. So when you have that sort of testing data also, this pie chart will change. Here testing data is not available and that is why it is 0%. But if you have that sort of splitting of the data, it will show you that training data is 180% and testing data is 20%. So that is also available here. So this option is okay, and this is again select multiple items if you want to select all together, or maybe you want to filter them, because once you upload thousands of data, the screen will be in a page-wise mode that you need to go on different pages to see them. But when you want to filter the data, you will be able to filter them using this sort of filter option. That maybe with title, with label, with frequency, number of things, you want to filter them by frequency of sensor. That is also possible. Okay, so now just show you that if you want to look at the data, you want to visualize the data, again, there is no need to write a code. It is directly available here. So as I told you that with no code solution, we want to develop some sort of machine learning application. This is a very interesting interface and cloud-based tool by which we will be able to do that. And all these options available on the left side of the pen are actually step-by-step process. You cannot click on dashboard and directly jump to live classification. You have to follow them one by one step. So initially you have to set up the board, select the devices, identify the data source, upload the data or maybe do data acquisition, and then finally go to the impulse design. That is the most important part of the edge impulse. So when you click on impulse design, you will be able to get the option. And now as a machine learning engineer, or maybe as a developer or as a professor or a researcher, if you do not have any idea that what sort of machine learning model I should select for what sort of data, what sort of technology I need to apply, don't worry, it will tell you. It will tell you that you have this sort of data and you need to use this one. Somebody asked a question, let me check the chat box. How do we justify these data are correct and accurate? I mean to say, like, see, the data are, when we are uploading the data, data are always correct or whatever way. If I'm shaking my phone, a random data is generated, but there is a specific movement. Maybe my shaking may be slow, my shaking may be fast, but it has to identify that I'm shaking my phone. So data is always in whatever raw format it is. Or you want to ask in a
Depending
different
on the
way, you can please
sensors or
help me.
sensitivity, it may be vary, no? Depending on the phone's sensor and sensitivity, accelerator sensitivity, so it may be changed, right?
Yeah, no problem
Yeah.
in that. But
So
all the sensors in the mobile phone provides you XYZ acceleration. So it may be in any way, but they are almost similar. It will work on any other phone also. That is almost a standard for them. So it will work definitely. So there is
and
no
also
issue with the data.
yeah, and also capturing the sensitivity. I mean the graph charts, and that is also a questionable, right? Depending
Yeah.
on the
And again,
uh,
it is a good question, because more the variety of we have, the more the accuracy we will be able to find out. Say, for example, if I am serious about collecting the data and every time I keep my phone perfectly vertical, and if I shake them exactly in horizontal direction, and I take thousands of sample in the same way, but I'm not having that sort of variety into my shaking data. So if I keep my phone a little bit slanted, if I keep my phone a little bit in horizontal direction, and if I move them randomly, but I'm again doing shaking. So it's a variety of data. So as even though the sensitivity changes, even though there is a variation in the data, even though there are noise inbuilt into that, it is good for us that more the data of variety data we have, we can bring close to the answer of the prediction of those particular gesture or the movement of the accelerometer. So that would be good. Say, let me explain you in a different way that I'm trying to build a model for person identifying the person's ethnicity. I want to find out that whether the person is Mongolian or Chinese or Korean or maybe Filipino or Taiwanese, Malaysian, Singaporean or maybe Bangladeshi or something like that. If I take samples of only few Bangladeshi living in India or maybe few Filipino available in India, and if I try to create a model that will be a kind of a little bit biased. It does not have much variety into that. But if I try to collect data from various parts of the world for this sort of ethnicity, maybe there are lots of variations. And even again, while collecting the data, if I take the passport size photograph or maybe a kind of a face cut only, then again it will be able to identify perfectly only for those data or the photographs when I show that passport size of the photograph to the camera of my machine learning application. But if I take the photo from different angle, different distance, maybe when the person is looking on the right side or the left side, I will provide more information to my data set, and that will definitely help me to build a better model. So I personally feel that whenever we are having data, it should have lots of variety, it should have lots of variation. Otherwise, what will happen that it will be a kind of a biased data set, and it will work for only those sort of things for which we have captured the data. So it is better that maybe we collect the data from different phones. Say for example, I want to create a very strong machine learning application, that I ask my student that you have maybe a Realme phone, connect with the Edge Impulse platform and collect the shaking data of shaking gesture, posture movement or something like that. If I have another Samsung phone or an Apple phone, I collect from that particular phone also. So maybe the company, the sensor which is made by different companies and deployed into various mobile phones may be different. Their sensitivity may be different. As you are right, it can be different, but it is good for us that we have variety of data for the same thing, and finally is going to give us a very strong model for the application. So when we go to the data acquisition part, and later on when we click on image impulse design, it gives us this sort of wizard. So automatically the platform understood that our data were time series kind of a data, because on the time series we have a kind of a plot of accelerometer data of XYZ, that what we have seen in the data acquisition tab. So it shows us this sort of information we have. Even the window size and the window increase size, or maybe the frequency of the particular sensor data is also identified and it is available. If you don't know much about those technical aspects of the sensor, no need to worry. But the thing is, what we need to do here is that we want to get some output features. Yesterday in the first session, we talked about a single chart where there was a, and then we had insight, and then we have feature and domain knowledge, and then prediction, and maybe the decision and feedback, something like that, the chart which we saw. There was an option of one block into that was about the feature of the data. So what we are interested is finding out the feature of this accelerometer data, that we want to find out some pattern. There is a kind of a similar pattern in every sample. Whenever we upload thousands of data, we will be able to see that there is a common pattern which we are able to see them inside when we visualize the data. So this is what the output feature what we require from that. But we don't know what I should do here. Add a processing block and add a learning block. So when I click on add a processing block, it gives me a very good suggestion in terms of what sort of things you need to do. So whether you want to do spectral analysis, whether you want to do IMU kind of an analysis, whether you want to use a flattened model, or whether you want to convert them in spectrogram, means if there is an audio data, you want to convert them into a visualized format of the pictures or the images, or maybe there are raw data. But now, if you look at this yellow stars, yellow star suggests that this is what you should use. There are lots of options. You can go with without suggestion also. But here it says that looking at your data, you should go with this sort of things. Right now, we have uploaded only 2 samples. So this may be completely wrong. But when you upload images of dogs and cats and label them with dog and cat, it will definitely ask you with tell you with the different option that you want to use. You should use this sort of image classification processing. So right now here, if you select this one, you need to simply click on add. It will add this particular spectrum analysis feature into this, and it will show you that there are 3 different axis data. It automatically identifies them. And then you can learn on add processing block. What do you want to process? You want to do classification, you want to do anomaly detection, kind of a k-means clustering, whether you want to do a kind of a KNN classifier, nearest neighbor classification, something like that. When you don't know about the label, even you want to do unsupervised learning, you can definitely go with the k-means clustering, whether you want to do regression analysis or custom classification. So until and unless there is no idea, it is better to select what the first option gives, is suggested to us. So maybe we click on add this one. So there would be a kind of a classification using Keras platform. And here it shows me the different labels. Right now only two samples were uploaded, so it shows me one label only because both the data has the single label which was about shaking. You may have different gesture data. Say for example, to create a machine learning application which identifies alphabets Z. If I write A, if I write B, if I write C, and if I collect data for A for 500 times, for B, I take the data for 500 times, and I use different users. Not I'm only the person collecting the data for A for 500 times. Maybe I take 100 data for my gesture. I tell someone to collect data for A again. So he may be having a different shape, size, or pattern of writing A in the air. Maybe I am writing a very small A, I'm writing a very big A, or maybe I am doing it very slowly. If I'm doing very fast, all the accelerometer data are going to change. And that is, if there are lots of variety of users are being generating this sort of data for the training data set, it will give you me a better model. So it is very important that normally when we ask the student to do some project, they try to do it their own. They take some of the samples with them only, and when we give it to someone else, it never works perfectly because there not much variety into the data. So we need diversity, variety of data, and it has to be collected from different source, different angles, different gestures, different movement, different speed, and finally we'll be able to have a variety of these sort of things. So once we have all these blocks ready, we can click here to save the impulse. Now there is no need to write the code. As you see that automatically the code will be created and generated later on, and we will be able to see the code completely, that it has been just by looking at the data we are able to find out the output model just by drag and drop kind of a facility or a wizard kind of a feature on the Edge Impulse platform. Now click on the save impulse and we will be able to get something. This is a dummy one because I have only uploaded two samples and that is also with the one label. But just to understand some fundamental features of the Edge Impulse platform, later on you can build your own. Okay, now it is saved, successfully saved impulse. Impulse is basically we are talking about some of the features which has been saved and processing and learning blocks in navigation bar. So now we can go to the second part, spectral features. When you are working with the Edge Impulse platform, you may come across number of options and features and you may not be knowing all of them. But actually, we do not need to use all of them because if you compare it with Microsoft Word, whenever we are drafting a single document, there may be thousands of features available in the Microsoft Word about different fonts and italic size, shape, color, underline, all these things. But it is not necessary to use all of them for our single document which we are writing. So whenever we are working on any of the project, it is not necessary to worry about all of them. So next, when we click on the special features, it has actually found these raw data or the raw feature out of that. So you can see there are some numbers being generated here for the data what we had uploaded. Even it the raw data graph plotted on the screen itself. If you click on the shaking label, it will show you the features for shaking label for data 1 and data 2. So you can visualize all of them. If I select this one, it would be different. If I select this one, it would be different. So this is just for your understanding. It shows you the spectral power or logarithmic scale, DSP result after filtering them. Don't worry if you do not understand anything. Just go ahead with the next part. So simply save the parameters and click on the neural network classifier. It shows us generate features for training set because right now we have the training set and data in the training set only 2 seconds, 2 samples. Class is also one which we had created or checking. Training window is 0. Calculate feature importance. If you don't know anything, simply generate on features. It will generate some of these 2 samples and it will be visualized here in the feature explorer. So the job has started. It is being running at the Edge Impulse cloud. Now if we click on this Eon tuner is not of much importance, or maybe you can skip that part also. But let us see on that part. It is specifically related to the hardware design. So this is for Eon tuner configuration, but right now we are not utilizing any part related to Eon. There is an option to retrain the model. If you see that the accuracy is less, you can retrain it. But initially, for the first time, you have to train it and then you can do the retraining. As we have not enough data, it shows that almost there. Now what I will do, I will show you that project in which there are lots of data and we'll be able to see the number of parameters from that. The project which I will open contains mosquito wing beat sounds of different species. There are audio samples for mosquito sound and their wing beat sound actually for Anopheles, for Aedes aegypti, and for third one, what was the name? And you can even share the project also. So in this case, actually, the project was being used by two different users. So if you may be working from another end, you can also be part of that project and you can share your details and you can upload your data. You can also change and see the project changes into that. So this is a kind of an option by which you can share with some team members. If there are 4 students or 4 faculty members who are working on the same project, there is no need to use the same login. They can have different logins. So this was by my student where we did the same work all together. So here almost everything available in terms of data. So let us see the data source, I mean to say. Okay, so here we can see that a huge amount of data has been uploaded. There is a training set for 79%, testing set for 21%. If you see here, as I told you that whenever we are dealing with any audio related machine learning application, one portion should be for noise, because when there is no sound of mosquito, it has to identify as a noise. So here, this is training and testing, and if we click noise, you will be able to see the noise sample also. You can play that also. There is a normal sound of noise, but when we click on some other samples, it will see us that this is for Aedes aegypti. There is a kind of a mosquito species. If we click on that, you will be able to listen the sound of that particular mosquito's wing bits. And again, all the samples are of 1 second. So when you have all these sort of data, you will be able to see that different sort of pie chart. The total data here are for 10 minutes and 60 seconds. Means every mosquito wing bit sound is of 1 second, and there are total 10 minutes of data uploaded. The complete data set was of 14 GB, but we couldn't upload almost all the data to the server of the Age Impulse. So we had uploaded some samples to that. And when you have enough data, you can see here that noise is for 1 minute and 59 second. Aedes aegypti sound for 3 minute 19 second. Anopheles is for 2 minute and 28 second, and 3 minute 40 second. Means 3 minutes means 60 into 180 seconds, and 180 and 14. So almost 198 seconds. So 198 samples are there for individual mosquito sounds. So here you can see them. You can identify whether the data is sufficient or not. Actually, it should be almost equal. So here it is 3 minute 40 second, 3 minute 90 seconds. So these are almost equal, but this is a little bit less. It is 2 minute 28 second, and even the noise is also a little bit less. It should be 3 minutes, 3 minutes, 3 minutes. Then there is a kind of a proper distribution of the data in terms of training data set. Now, when we click on create impulse, now as it is a audio data, but we want to classify them, so it will give us an option that what sort of impulse you have to use for classification. So as the project was already gone through all the steps, so it has directly shown us the audio MFE option and classification using Keras, and the impulse is also being saved. Now the thing is, as you move on the implementation part, or maybe you have trained your model, you have got some very good accuracy. Now the problem is that sometimes you deploy, everything is good, you are getting very good accuracy, but when you implement it on a hardware, you are not getting anything. It is not at all working. What can be the reason? Now the question comes is all about identifying the sir has told that you need to look at the sensitivity, you need to look at the hardware specification. For example, when the data was collected for mosquito sound in this one, a kind of a different microphones might have been used, or maybe a microphone having different sensitivity. But when you are using your Arduino, it may be having a SMD, kind of a very small phone on board, and that specification of that particular hardware microphone may be different, which may be not able to capture the sound within few seconds. So here you have to change some sort of window size, whether you want to capture the sound within one, you want to capture the sound in few milliseconds, then it will start working. So initially when we started working on the project, actually it was not working at all, but on the Edge Impulse platform, it was showing us very good accuracy. It was able to classify the sound of different mosquito types and showing us the species of them, but nothing was working on the hardware. So when we look at these parameters of window size, window increase, decrease, etc., we found that after changing those window side, it was able to capture, because when we had selected the data for training and testing, it was of 1 second sample. So I mean to say 1 second, if the window is bigger than that, it is not going to capture them properly, and it will not be able to identify, because two different samples will be mixed up. So it is better that if we capture the sound below one second, it would be better. So 180 millisecond or 500 millisecond would be a better option. When we look at this part, create impulse, classifier. You can even add number of other processing blocks also if it is required, but usually they are not required. If you want to play with them or maybe want to do some research, it is better you add number of blocks, identify the effect of them. If you can find something new that can be a good research outcome, or writing a paper also, it can help us that okay, this sort of more number addition of the processing blocks help us to increase the efficiency or to get a better model. So here you will be able to see that there is a confusion matrix which shows us the correctness of the label identification. So it has also generated the code. The similar thing also available here, what we had seen in the Google Teachable Machine, that training settings, etc. What all options are available. It has also created the generated the same code which we normally write in our machine learning training model. And if you want to do again some training by changing the code, because the code is generated automatically by the algorithm which is running on the Age Impulse platform, but this is a very standard code. I mean to say, whatever GitHub you repository you refer, or whatever blogs and articles or the tutorials or the documentation page you refer on Google, Nvidia, Amazon, any website, you will be able to see the standard process and method which is being used for writing at the training of the model. So if you are interested in playing with some of the parameters, what you can do that change this. Say for example, this line shows that epoch is equal to something around 30, or the training rate is 0.005. You can change here to 0.001, again do the training and look at the accuracy, whether there is a change or not. Most of the time it would decrease actually. So the code which they are generating are basically the optimized one, the perfect one, and it gives you the maximum accuracy. But even though as a researcher you want to find out that let us find if I change the learning rate, if I change the epoch rate, if I change some layers into this one, whether there is an effect or not. If you look at this part of the code, maybe this is something like a kind of a repetition of the code. If you completely remove this portion and again do the training, you will be able to see that it affects the accuracy. Now when we have created and trained training, we see that this particular confusion matrix is a very good method of judgment for the judgment of the accuracy. When you look at this particular confusion matrix, it shows that how it is performing well for identifying Aedes aegypti, kind of a data which you had already uploaded for training, and while testing the model, whether it is working fine or not. So it is all about a measure of a validation of your accuracy. So it shows that for Aedes aegypti, it perfectly finds out with 93.5 accuracy. For Anopheles, it is perfectly finding with the 63% accuracy. So this confusion matrix actually gives us a hint that whenever you will deploy this model, there are chances that it can identify Aedes aegypti perfectly, because the confusion matrix has a kind of a score of 93.5. But for Anopheles, it is not able to find out perfectly. It shows something around 63%, 63.8% of accuracy. But for QLEX, it is fine. For noise, it is fine. There is no problem in that. So we need to see that how we can work on those data for Anopheles, whether the data is not sufficient, whether there is not much variety. There are chances that for Aedes aegypti, maybe I have uploaded 1000 samples, and all of these 1000 samples are having variety of or maybe from different mosquitoes they have been recorded. But for Anopheles, maybe there are 1000 samples which has been uploaded, but there are chances that it has been recorded for only two mosquitoes for 500 times and 500 times. Maybe for new mosquito of Anopheles species, it may not identify it perfectly. So we need to go back again to look at the data, whether they are all similar in nature, whether there is not much variety into them. That can be the reason why it is giving you 63.5. There are chances that you may get sometimes 50%. So maybe your model is good, but for some specific class identification like Anopheles in this case, it is not able to judge well with a good accuracy. So overall accuracy will increase if your accuracy, which is shown in the green labels for individual labels below the individual labels, if it is good, your model accuracy will increase. So in this case, case, if the Anopheles confusion matrix accuracy increases to say 70%, maybe the overall accuracy can be 90% here. So this is a very good representation in terms of visualization of the data. Even you can see that how the data are visualized here. If you can drag and move it here, or maybe you can expand it here a little bit, you will be able to see each and individual sample, how they are distributed, how they are clustered. So you can see that this green bunch is basically for noise or QLEX. Almost they are close, and that is why we are getting very good accuracy here. This one, red one, is incorrect. So this particular sample is basically a incorrect sample, or maybe there is a problem into that data which is not able to perfectly able to identify. So here you can see that there are again some few data here on the corner of this particular 3D projection, that they are also clustered, and maybe you can see the name of that sample. It shows you the complete file name of the sample which you have collected. So the best way is to either note down this particular file name, go to the data set, remove it completely, upload with some new data, or maybe you can simply remove them. So sometimes it happens that these are basically something similar to the outliers, what we call. This can change your result completely. If we remove the data completely from the data set for this particular cluster shown here in a very small amount of data, this can be a problem for bringing out a better accuracy. If I delete all this, maybe I can identify that, okay, this belongs to Anopheles, this belongs to Aedes aegypti, this is for QLEX, and these are the name of this data sample. Go back to the data set, remove them, and try to retrain the model again. There are chances that the accuracy may go beyond 90%. So this is also a very good option by which we are able to identify and visualize them, and we can understand the distribution of the data also. You can click on any of the sample here, like say for example, I just simply zoom it out, and there are few samples here. If I click any of the sample, I will be able to see that sample, and even I can play the sound of that. So even view sample, view features, you can even view the features also. So it gives you a very close understanding of the data, that whether you want to change anything, whether you want to remove, whether it actually affects your overall performance, that is very important. Just to understand that if we have a data set or the database of 10 students and the result, and out of these 10 students, we have 8 students who are having of say more than 95% in their mark sheet, and if we have 2 students who are actually failed, so these 2 students are going to change the complete result of that particular 10 data samples. So sometimes it happens some outliers try to change your accuracy. So it is that to bring out a very good accuracy, it is better that we have some sort of visualization, data pre-processing, data cleaning. Sometimes some of these samples might not be having the complete data in terms of value. It may be 0 0, or maybe they are nil. So total count is counted, but there is no data at all. And finally, it is also one of the reason which actually changes your output, or maybe the machine learning model efficiency. So this platform provides you a kind of by looking at this accuracy. So this is the final accuracy. This is a kind of a loss in terms of model accuracy, but this is possible that we can enhance, we can improve. So now if you see that if you are interested in doing some research on any of the classification problem in the world, you may look at some of the archive papers, you can download them, you try to deploy and implement the same paper with your expertise, and you out that same accuracy. Okay, that paper is a kind of a standard paper which shows that a kind of a classification accuracy of 93%. Now as a researcher, you want to explore it more, you want to dig it further. What you can do is that you can deploy, or maybe there are some websites which are known as papers with code. These are some of the popular websites, world's popular papers. People write the code for them, they put all together the implementation of that paper. You can use that sort of to learn something. You can deploy here on Edge Impulse, and Edge Impulse is going to generate the code for you also. So it is better now that you do some alteration in the code, try to modify some of the data and bring out more accuracy. So that can be a little bit further addition to the existing research which has been done. and your contribution can be how you improve that particular existing model by doing some sort of research into that. So this is a very small part which we can give student for their master's thesis and try to allow them to explore, because as a student it becomes very challenging when they try to implement someone's paper into a code or maybe on some platform like Age Impulse. So that would be also a learning experience for later on. They understand once everything in a better way, they try to put provide their value addition contribution to the existing research. So in a way, if you write a code, it runs on your terminal, and if you are not able to see anything, it is better that this sort of platforms gives you a kind of a visualization, that you see that how the data is distributed, how they are clustered, what are the different points which are basically useless and we need to remove them. So this is a view for that. Even it shows you a kind of an on-device performance, that okay, the model is ready having an 88% of accuracy, and when you will load it on a Arduino microcontroller, it's going to give you 45 millisecond of inference time. So it will take that much of time to input the data to the model and you will get the output. So that is basically the inference performance. How much RAM it will use? It will use 9.5 KB of RAM only. So you can understand that the AIMPulse actually converts the model into a very small size. Flash memory will be around 5.9 kilobytes. And later on, if you see live classification, the platform also gives you an option of looking the classification the platform or into your account directly without even deploying on the hardware. Okay. Now, as we see in the first option of the dashboard and devices, chances that you might have connected your mobile phone accelerometer to test now how does it work. So there is an option that to classify the new unknown data with your existing model. Either you can connect using web USB, or maybe you can select your device here, or maybe you can select any sample directly. You can load this sample and you can check your model's accuracy by testing data, or maybe unknown data you need to upload on the cloud of Age Impulse. Okay, so now this is the one of the sample which I use for from this particular drop down. This is from the testing data which has been uploaded for various mosquito species, and when I clicked on load sample, it has got loaded here and it has even classified. So now I can see that it gives me the accuracy for this particular, no, not the accuracy, but it gives me the classification for this particular outcome. It was basically a noise data and it has accurately identified as a noise. And these are some of the features of that particular sample. So you can even test a single sample by checking them whether it is working fine or not. Okay, now moving towards the deployment part, because model testing performance calibration would be simply to click on the buttons which has been provided. Okay. Now, once you have gone through all the steps, you have your model ready, everything is there. Very important part is deploy your model. Let me first of all click on model testing here. Let us see that. So this is when I click on model testing. If I want to classify all, it will be able to classify. So that part I didn't click, but I wanted to show you. Then performance calibration. So here you can check with some noise levels or maybe the data which has been uploaded into different categories. In our example, it is about 3 different species of mosquito and noise. So you can check whether are there any other labels that should be ignored by your application if you have uploaded some data and you want to do that sort of performance calibration, or maybe you have any other audio kind of a format to test and performance checking can be done. Now moving to the last part of deployment. Versioning gives you an option of different versions, because whenever we are working on any of the softwares, the first version may be version 1.0, 1.1.1, or maybe 1.12, etc. So this is something related to putting up your all different models which have been trained as a different version on the cloud. When you are actually seriously having a kind of a working on some project and you want to keep all the versions ready with you. Okay, now our target of using Edge Impulse basically to make some embedded machine learning application. So now everything is done, data was uploaded, training was done, model is created, efficiency is checked. Having good efficiency, you have created some model. Now it is time to run it or to deploy it on some hardware. So we have 3 different options. The first option is basically to create the library. Second option is build the firmware. And third option is run your impulse directly. So what is the difference among all these? Create your library means in Arduino we use .h as a library, or maybe in case of C programming also we might have included like console.io.h or math.h. So what exactly the library contains? Library contains almost all the requirement of those functions which we try to use into a program is available inside that, and this particular library for from Edge Impulse created for different versions or the variants of different platforms. Like if you want to create a C++ library, you click on that, it will create a C++ library and you can use it for your C++ computer program. If you want Arduino library, it will download a library called model.h, which you can use for your programming the Arduino. You can include model.h. You can add .header file into by going to your Arduino IDE and you can use them into your program. So this is something about creating the library or the header. Usually it is similar to a model.h file for normal computers. When you create this Arduino library, it actually uses TensorFlow Lite technology for microcontrollers. It reduces and shrinks the model to a smaller size. Usual model may be 150 MB, but for Arduino it would be 20 KB only. So that is what the main purpose of utilizing the TensorFlow Lite concept and the framework for shrinking the model to a smaller size. So this Arduino library will basically create a library for Arduino, and then you will be able to download that. So once it is created, your Edge Impulse will allow you to download that library into your local machine. Then you go to your Arduino IDE, import that header file and use it. So that is one option. Second is all about building the firmware. So now when you are talking about the firmware, it is always goes to most of the development boards which are available. So the supported board for which the Edge Impulse can create the firmware are available and listed here. So the recently added was the Sony S Presence board. It is again a very interesting board. Even you can write to Sony research for getting this board. Last year, IIT Madras has organized a kind of a very good event in with Sony Research Center for developing some sort of tiny machine learning application, and they had given lots of Sony S Presence board to the faculty members for doing that sort of innovative research on the board. So this is something related to creating the firmware. Now the difference between a library and the firmware is all about when you buy an Arduino from shop or from the Arduino's website, it comes with an inbuilt firmware. So something like an operating system, I should say, maybe which is responsible for utilizing various pins and sensors or data communication and number of aspects. So it is a kind of an inbuilt software, which is basically a firmware, and which allows you to write a code and use number of features. But when you are creating a specific built firmware and implementing or loading into an Arduino, finally it will be used for that particular application only. So just to give you a similar example of, you might have your washing machine or maybe an oven into your home, and that has lots of options. So the chip is basically loaded with a firmware to work with that sort of thing. You cannot program that particular microprocessor of your washing machine or maybe a dishwasher, but that will run, or maybe it is built for that firmware only. So if you want to use your Arduino Nano, that I want to use it for that application specific kind of a thing, then there is no need to even write a code for Arduino, but it will directly give you a firmware and flash out your Arduino Nano with that firmware. Then forget about that thing. So it will help you to build a firmware. So these are the different targets of different vendors who have created the development boards which supports machine learning are listed here. So select any of the target and then click to build the firmware. It will build a firmware, and finally you will be able to download that firmware into your computer. Third option is basically run your impulse directly. You are not interested right now in implementing or deploying onto any hardware. You do not have that sort of device. So you can check them on your mobile phone directly. It will be connected through again the QR code or a web-based interface from your account of Edge Impulse in your phone application. So that's the third option. That will not help or get you any model or any firmware, but that will help you to test on their interface only, on the cloud interface of the Edge Impulse only. So just to check, it is fine to run your Impulse directly from the computer or the mobile phone. And this is something about the optimization of the compiler for looking at the performance of the this one. So maybe if I click here on the Arduino header file, and if I go here and see that this is going to have this sort of optimized model, which I will be able to build, and later on I will be able to download it. And that would be the last part of this particular Edge Impulse process. And then finally you will be able to run the application, or maybe rewrite the code, or maybe write a Arduino code, write a code for Jetson Nano, write a code for Raspberry Pi, any Linux platform. Here the Linux board is, it means that there are number of Linux boards available in the market like Banana Pi, Raspberry Pi, all these. So they are common. There is no need to have a separate boards to create the firmware for them, or maybe to build the firmware for them. But it is better that you select the Linux board. It will work on any of the Linux based platform of embedded system. So this is a kind of a very interesting platform that now if you understand that even if you are not interested in writing the code, if you are going to use the cloud platform, which is a kind of a very interactive one, where it helps us to decide the algorithm or the architecture or which sort of board we want to use. Again, it takes some time to understand the complete process, and sometimes as a beginner to start with, it may take you 4 to 5 days to set up everything to use this platform, because within a 1 or 2 hour of session you might find it very easy to use it. But once you start working on it, initially you need to set up something for your Arduino specifically, and for your Edge Impulse connectivity with the board to the cloud. So that may be a little bit tricky sometimes. If everything goes fine, then in the first instant it will start working. Otherwise you need to find out what problems you are having to run the Edge Impulse platform with the hardware of your choice, which is connected with your computer. So I think now today we covered about the Google Teachable Machine. We talked about the App Inventor by MIT, which again gives you an option to train the model on their platform, similar to the Teachable Machine. And the third option was to target specifically the embedded system using Edge Impulse platform. So these are all three options applies to them who wants to rapidly build some application. They are having the data, or maybe sometimes they are having a problem to collect the data also. It is a better option that you go directly with this sort of platform, and you will be able to at least see your application running on the platform like mobile phone or maybe the embedded system. Because for computers, it is already there. There is no need to use this sort of platforms. So I think we'll keep some time for question answer, and then we will finish the session for today. So I will stop sharing my screen and
Hello. Hello.
yes, yes,
Sir,
please.
there is one question that for using this the Age Impulse platform, first
Hmm.
we have to create account in this Age Impulse.
Yes, you need to have a kind of a login account. That is a normal process.
Normal process. Okay. Okay, sir.
It's free. It is free. And again, the utilizing the all the features of Age Impulse platform is free. There is nothing paid on the Age Impulse website.
Okay, sir.
Anyone else?
Someone has written a question, is there any limit for data on cloud computing? In most of the time, when the resources are free, like say Google Collaboratory, you can upload as much data you can. But once you log out from your session or your Google Colab session, they automatically flushed out all the data. So they do not store it. So maybe for beginner or maybe a kind of a normal user, if you do not have access to your Google Drive, if you have a Gmail account, normally they provide you 25 GB or 15 GB of usage, right? The total storage which is given to you. So you cannot upload more than that. But if you have a 100 GB of paid account, maybe you are paying 130 rupees per month for Gmail account. At that time, you get 100 GB. So 100 GB can be your limit. You cannot upload more than that. But again, the Google Colab gives you an option that whenever you upload it, any of the data, maybe if it is a 2 KB of file or maybe a 20 GB of data, it will flush out once you log out from your Colab session. Where we are using this age now, sir.
Thank you, sir. Thank you, sir. Thank you very much.
Where we are
Sir,
using this age now. Age
sir,
means,
one more question again.
yes, please.
Sir, one more question. If suppose I have to build a project for a disease prediction of crops,
Yes.
so can I get the all this the data set online?
Yeah, there are lots of weed detection kind of a thing. Data is already available. You can use them. But again, it all depends. As I told you that maybe you have downloaded it, weed detection, or maybe a kind of a the problem in the farm, the leaves, or maybe there are some disease in the agriculture area. The data may be of say any other country, it may not be from India, or maybe where you are living the crops are totally different. So sometimes that sort of data set may not be much helpful to us. So it is better that first of all we collect our own data. Maybe again it is a very small amount of data, but we start with the data where we will be able to see the result, because finally for testing you are going to go to the next farm or maybe any land where there are some sort of disease in the farming. You will be able to test them. So that is the first thing, that use your own data. And if you are not able to find out any, you can definitely start with some sort of other available resources of the data.
Sir, suppose I will take the 100 samples of some 100 samples of means 100 sample of some leaves which having the no disease, and that data I will upload it on this the data that will uploaded on the teachable machine platform.
Yes, it
Okay,
will work
and
fine.
suppose I will go to the garden and take one of the leaves, and I have to upload this. Then how it will compare with the already sampled data?
It is all about like, sir, convolution neural network. Actually, we didn't went to that much of detail, but whenever we are actually, using a classification problem, say today I show three different class for image classification, for glasses, for duster, for mobile phone, etc. So whenever all these images were being uploaded and when the training was done on the platform, actually the code, what actually the code did for training, it took one image And normally any image is any image is made up of RGB component. So actually it separated R part of the image, G part of the image, and the RGB, I mean to say red, green and blue. Then if the image is of, say for example, 32 by 32 bit or 32 by 32 pixels, it means that for R I have 32 rows and 32 columns, a single image of R portion. Then for G again 32, and for blue also 32 by 32. Now using a matrix filter of say 3 by 3, so a 3 pixel by 3 pixel of sample filter which I run on single R or G or B images. So the matrix multiplication gave me some sort of result in the matrix outcome of those pixel values. Now using some sort of other methods to get, say for example, in a single matrix of 3 by 3 I might have a 2 by 2 matrix, and in this 2 by 2 matrix I have one value called 1.2, 1.3, 1.6 and 1.7. So 1.7 is the largest one, so I will not take all these four values, but out of this 2 by 2 matrix I will take only 1.7 and I will create a new matrix. But what is this, what is the purpose of doing this is basically to shrink the image to get a minute version of the image. So maybe a 32 by 32 image I may get a single pixel for that, and that would be the game changer for identifying the result, which may be the close to that. So the convolution neural network, there are a few videos I will suggest you to see that how actually the classification is done. Whenever you show an unknown image to the model and it gives you a perfect result, what happens actually inside that. There are very good videos for visualizing the concept also. So I will suggest you to refer some of them. It is a bit more technical if I explain right now.
Okay, sir. Okay. Sir, please kindly share your number, sir.
Yeah, I will write my number here and email address. You can definitely message me, call me at any time.
Excuse me, sir.
Yes, please.
Sir, if we have collected data and as there is a memory limitation, can we first reduce our data or that is better process our data, compress our data, and then if we apply it to teachment, will it help improve the accuracy, or will it affect the result or accuracy?
Okay, there are two, three aspects. Say, for example, normally when we are using our computer, a normal computer system, what we have, so it may be having GB of RAM or a very high-end processor, which may be the best in the market right now. So we may be using the same. More number of data is going to take more time, for example, for training. It is going to be definitely work because at an instant, it's going to take only one image. But if your computer is not having a GPU or maybe a GPU cluster of that, or maybe it's not a server, at that time, your computer may be taking 1 hour of time, sometimes half an hour of time. And maybe if you upload those data on Google Colab, it may be doing the same thing in 20 seconds because they are having lots of high power computing devices available over there. So having more amount of data is not going to affect you much, but it is going to take your time. That is one thing. Second thing is, if you look at your data and if you do not have more variety, but only a kind of a duplication or repetition of the data, that is again useless kind of a thing. Because if I have collected the data of different dogs, but there are 100 pictures of the same dog, it's not going to be a very useful information or data for me. But if I have 100 different dogs photographs, then it is going to be really useful for me. So we need to sometimes see that whether we have some sort of duplicated data or maybe similar kind of a data, it's not going to give us, or maybe it's not going to be much useful for us for having a better. So that is second thing. Third thing is, it all depends on which sort of you are targeting, whether you want to test some prototype or maybe you want to start with some. There is no need to look at GB of data. It is better that you go with some 100 photographs or 500 photographs. First of all, try and test whether you are able to fulfill and go through the process and you are getting able to get some output or not. Once it is done, then it is all about increasing the quantum of the data or the scaling of the data and do the same process. So once you start with say 14 GB of data and you take too much time, you do not have much resources, finally you will not be able to get anything out of that project. But we start with a very small amount of data, maybe 1000 or sufficient data I should say to start with. And then later on, if everything goes fine, and what is the purpose of doing that particular project or doing that work, finally if it is going to be a very good business problem or maybe a kind of a startup is working on that and they are interested in taking your guidance or an advisory kind of a thing, you can later on think seriously about how you can do that. Because I've seen there are lots of startups in Bangalore who are working on machine learning problems for speech data, having lots of high-end GPU cluster computers, even though they take sometimes 1 week, 15 days, 3 months of time to process the data. But being a faculty or a student, for us, it may be not it may not be a big business problem. We may start with some small amount of data, and then we can finally at least prove that, okay, this is going to be a kind of a flow of the process, it works. So as a learner, as a beginner, no need to worry about the huge amount of data. You can start with small ones. Any other question, please?
Any other question?
Okay, I hope that the last session was useful because some many of the things are not possible to cover within 2 hours of session until and unless we personally log into the website and we explore number of areas. But a kind of a hint which I tried to give you on 3 different platforms today. No doubt the Google Teachable Machine is one of the most easiest one, and I suggest all of you to even tell about this platform to your son and daughter who are in school or maybe high school or college. That would be really helpful to them because within few minutes they will be able to make some sort of classifier with mask and without mask, or maybe they are able to identify the voice of the persons in the family also. So even that will be very interesting for them to learn and deploy something quickly without knowing anything.
Yes, sir. It was such a nice session and very informative. Though it is exhaustive one, but wonderful session, sir.
Anyway,
Yes.
thank you so much.
Thank you so much, sir. I extend
Thank you,
my
sir.
thanks
Thank
to
you so
Dr.
much, sir.
Kiran, sir, on behalf of UGC HRDC Nagpur. I thanks Dr. Kiran, sir, for all the 4 sessions. All the 4 sessions from day 1 to today also. Thank you so much, sir, once again.
Thank you all the participants and see you sometimes again in the future.
Yes, sir.
Thanks.
Yes, sure.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Have a nice day, sir. Thank
Thank
you.
you, sir.
बाय बाय थैंक यू ऑल ऑफ यू यहाँ पे रुकते हैं हम कल का अपना शेड्यूल एज इट इज रहेगा 11 से 12:30 और 1:30 से 3 बजे तक 2 सेशंस रहेंगे आज का आपका टास्क है रिपोर्ट सबमिशन ऑन ऑल द 3 लेक्चर्स एक ही टास्क है आपको रिपोर्ट सबमिट करना है तीनों भी सेशन पर ठीक है
मॅडम लिंक नाही मिली ती का हॅलो
सर आज टाकलेली आहे मी रिपोर्ट सबमिशनची लिंक
दोन्हीचे ना आज आणि
हाँ नहीं नहीं कालचा नहीं सबमिट कालचा डेमोन्स्ट्रेशन मोड होता ना सर कल के इसमें आपने बहुत कुछ लिखना पॉसिबल नहीं था क्योंकि टेक्निकल सेशन था वो ठीक है तो कल वाले का कुछ भी नहीं करना है आज के जो 3 सेशंस हुए उसी के ऊपर आपको रिपोर्ट सबमिट करना है और वीडियो की लिंक बोल रहे हैं शायद कोई तो भी चैट बॉक्स में मुझे दिख रहा है
मैडम काफी डिटेल है
हाँ तो मैं अभी ये सेव होगा पूरा 3 घंटे का I will upload. First session I have uploaded Malik madam session. Now these 2 session I will upload because it will take time to save and upload on YouTube. So I'll upload by 6 o'clock. जैसे ही ये यहाँ से खत्म होता है उसके बाद में अपलोड करता हूँ ठीक है वो देखने के बाद भी आप लोग रिपोर्ट सबमिट कर सकते हैं रात चलिए थैंक यू ऑल ऑफ यू
Okay, madam.
थैंक यू